Okay, so we have hit the all-important time where we get to real factoring. I mean lots and lots of real factoring. So part of what I like to do in my class is make it as simple and basic as I possibly can. So I start with the Factoring 101 chart that's behind me. We're going to add a little bit to it every day, but our little bit will get to be quite a lot because the chart gets bigger and bigger and bigger. So I want you to write it like I have up here every day. What that means is today we'll write what we know, and then the next day you'll write it fresh. You won't just add to it, you'll write it fresh. That'll help you remember stuff better. So, and we'll add the little bits that we get. And that's what we're going to do so that we can try to remember all of this factoring, because it gets really long and really tedious. So go ahead and pause the tape when I move out of the way so that you can write down all of this that's up here now. Then I'll explain it while you're not busy writing. Okay. All right. Factoring 101. The first step whenever you start factoring is to take out the GCF. We talked about that 2 sections ago. No, in the last section we talked about that. See how it all just kind of blends together for me? We talked about that in section 7.2. We found a GCF in section 7.1. We talked about it in section 7.2. And technically we're starting in section 7.7, which is where our work will be at today. But we're really just starting factoring. And when we go back, we'll still be in the middle of factoring. This is just the way it runs better for me. So the second step in factoring is to always count the number of terms. You have 3 options. You can end up with 4 terms, 3 terms, or 2 terms. If you end up with something different, then there's an issue we need to deal with later on. If you have 4 terms, your only thing that you'll be able to do is to try grouping. It doesn't mean that grouping will work. It doesn't always work. But usually you can make it work. So the steps in grouping are to look at the first 2 terms and take out their GCF. Then look at the last 2 terms, because you know there are 4 of them, and take out their GCF, and then you take out the common GCF. It sounds really simple, looks really complicated. Let's look at a problem. I'm looking at number 24 out of your book on page 294, if you want to turn to it. It's the problem 4wx minus 6wy plus 6xz minus 9yz. So whenever you start a problem, you always have to start at the very first step. People like to skip it because it's up here. It's not down here. It's not the stuff we're practicing on all the time. But it really is, because we really always look to see if there's a GCF. So is there a number that goes into 4, 6, 6, and 9 evenly? Well, no, we got a number that can go into 4 and 6. But not a number that goes into 4 and 9. Because the only number that goes into 4 is 2. The only number that goes into 9 is 3. So that means there is no GCF with numbers. Is there a W in every term? No, because this doesn't have any W's. Is there an X in every term? Well, there's one there, but there's not one here, so no. Is there a Y in every term? No. Is there a Z in every term? No. So no GCF. That's okay. It means you go to the next step. Our next step is to count the number of terms. We have 1, 2, 3, 4 terms. I know that because terms are always separated by plus and minus signs. So that's 1, 2, 3, 4 terms, which means I have to come over here and try grouping. So the first step in grouping is to look at the first two terms. So I'm only looking at these two terms. And when I look at those two terms, I'm supposed to take out the GCF for just these two terms. Well, is there a GCF in the numbers? Well, yeah. 2. 2 goes into both. So I take a 2 out. Is there a GCF in the letters? Well, yeah, there's a W in both. So I take a W out. When I take 2 out of 4, that leaves me with 2. I take the W out, leaves me with an X in. Minus. Take a 2 out of 6, 3, because remember we're dividing, so 2 goes into 6 3 times. Take the W out, that leaves me with a Y. This is all one term. I know that because it's all multiplied together. That makes it one term. Over here, step 2 is to look at the last two terms and take out their GCF. So these are my last two terms. If I'm going to take out their GCF, out of the numbers, I can take out a 3. So I'll put a plus because it's a positive 3. Then they don't both have an X, but they do both have a Z, so I can take out a Z too. 3 goes into 6 2 times. My Z's go away, but I'm left with an X. And then 3 goes into -9, -3 times. My Z's go away, but I'm left with a Y. And that's all one term. Step 3 says to take out the common GCF. Well, since this and this is in both, you know, the stuff in the parentheses is in both, and since it is exactly the same, I mean exactly the same, 2x minus 3y and 2x minus 3y, that means that it is like a factor. So I can factor that out because it both have it. So when I take that and make that my GCF, whenever we take out a GCF, we write it on the outside, and then we put parentheses, and then we divide. When I take this out of that whole term, I'm only left with this little bit, the 2W. And when I take this whole thing out of that whole term, I'm left with the plus 3Z. That's why this is my answer. Now, if you don't believe that that's your answer, you could always sit there and multiply it back out. Now, I know that you've written all this down, and you've paid attention to it, and you understand it, but I want you to stop anyway. I want you to rewind the tape back and listen to everything I said about number 24 again. The reason is some stuff happened in here that's really confusing if you don't catch it right. So go ahead, rewind the tape, and listen to it again. You don't have to write it down again, just have to listen to it again. Focus on what I'm saying and why I'm saying what I'm saying. Okay? And then we'll go and try another problem. Okay, let's look at this problem. Let's get a different color. AB plus B squared plus CA plus CB. They want me to factor it. That's the only directions they give is to factor. So I'll look and see if there's a GCF. There are no numbers, so I don't have to worry about that. Are there any letters that are in every single term? Well, this one has an A and a B, but it doesn't have a C. So I can't use C. This one doesn't have an A, so I can't use A. And this one doesn't have a B, so I can't use B. So I don't have any GCF. How many terms do I have? 1, 2, 3, 4. 4 terms, which means we have to try grouping. So I'm going to look at my first 2 terms and see if they have a GCF. And they do. There's something that goes into both. So since B goes into both, B goes into AB A times, plus B goes into B squared, B times. That's simple enough. Then I'm supposed to look at the last 2 terms and see if they have a GCF. Well, they do. It's a positive C. Make sure you always put the sign that's there. So since I'm taking a positive C out, that's going to leave me with an A here plus a B there. Now, because this has A plus B and that has A plus B, that means that I can take that GCF out of these 2 terms. When I take that GCF out, I have to write my second parentheses. And then I write down the stuff that's left over. So a lot of my students end up saying the first parentheses is what the GCF was, and the second parentheses is the stuff that's left over. The stuff that's not in parentheses, because that's what it ends up being, B plus C. Now, the second question I always get about this is it okay if I put the B plus C here and the A plus B there? Yes, that's fine. As long as you have the B plus C grouped together and the A plus B grouped together, you have the problem right, no matter which one comes first. Because we follow the rule of commutative property, and it doesn't matter which one comes first for multiplication. Let's try another one. Sometimes they like to kind of help you out and start you in the middle of a problem. So you'll get something like 2a times c minus d plus 3 times c minus d. Where they've already factored stuff out. You don't want to sit there and multiply it out. Try really hard never to multiply in factoring, because that's always undoing what you're supposed to be doing. You're supposed to be breaking it down, not multiplying it together. Just because we leave it as a multiplication problem doesn't mean we actually want to multiply. So they've already broken it down halfway for us and taken out GCFs. So we just have to look at this one term and that one term and see what they have in common. And then see the stuff that's left over, which is the stuff that's not in parentheses. We put it in parentheses. If we had to check our work, we could always take this and take that and multiply them together using that distribution that I showed you from chapter 6, and you would end up getting what you would get if you multiplied and worked that out. Over here, if I multiplied it out, I would end up with AB plus AC, which is right there, plus B squared, which is right there, plus BC, which is right there. You end up with the exact same thing. Not necessarily in the same order, but the exact same thing. One more problem I want us to look at. This one. I want you to pause the tape and try it. Okay, so when we're doing this, we're supposed to see if there's a GCF. Is there a number that goes into all of this? There is. 2 goes into everything. So I need to start by taking a 2 out. Now I know you didn't find that. I know you jumped to grouping. You did that because that's what we've done in all the other ones. But every single time I always looked for a GCF first. So you need to make sure you always look for a GCF first. Now you notice when I did this, I left it as big old brackets. That's because we got a lot of parentheses going on inside of our problem, so I don't want to get confused by anything. So I go ahead and put brackets out there if I take out a GCF on such a long problem. So when I take a 2 out of 32, that leaves me with 16x squared. 2 out of 16 is 8xy. 2 out of 2y squared is y squared. And 2 out of 18 is negative 9. Going to conserve a little bit of space here for my next line so I can get them all in. I have 4 terms left inside, so that's still what I need to factor. So I leave this 2 out here because we don't want to lose it. I just don't want to mess with it anymore. So when I look at the first 2 terms to do my grouping, I can take an 8 out, and then I have an x here and an x there, so I can take an x out, but not more than 1. So inside, that leaves me a 2 and an x minus, here when I take the 8 out, I don't have any numbers left inside. Take the x out, they cancel each other out, I just have a y. Over here, there's nothing I can take out. That leaves me with y squared minus 9 over here. If there's nothing I can take out here, then there's nothing I can match with anything here. And if these 2 parentheses don't match up exactly, then you can't use grouping. And there's nothing I can do to make these match up exactly because one has an X and the other one doesn't. So grouping won't work on this. And since we found out that grouping won't work, that means that I need to go back to the last thing that did work, which is that. We could take a 2 out, and I did take a 2 out, took out my greatest common factor. But there is nothing else that we can do with this. Remember I told you there was only one option for 4 terms. That's it. If it's not grouping, then it's not going to happen. And this is your answer. And it's okay to leave the brackets in there, or if you want to replace them with parentheses, that's fine too. Grouping doesn't always work, but my method will always work for it. Did that one there. Okay, so classwork for this section. Page 294. Practice exercises. Numbers 15, 21, and 25. And then homework for this section, same page. Same practice exercises. Numbers 27 and 29. Not a lot for this section because grouping, while it's important, is not all that there is in factoring, and it's not what you use the most. So, see you next time. Bye.